In this part, we're going to explore conversions in Go. Conversions allow you to work with variables of different types by converting one type to another. This ensures that operations between different types can be performed without errors. Here's a simple Go program where we declare two variables, length as a float 32 and width as an int. We then attempt to calculate the area of a rectangle and compare the two values. Let's run this code to see what happens. As you can see, we get an error. The operations between length and width fail because they are of mismatch types, float 32 and int. Go doesn't allow math or comparison operations between variables of different types. This strict type enforcement helps avoid unexpected behavior in programs. Let's try to assign the int value of width to the float 32 variable length directly. This code will throw another error because Go enforces type safety when assigning values to variables of different types. Direct assignments between incompatible types are not allowed. As expected, the code produces an error. We cannot assign an int to a float 32 variable directly. The error message informs us that Go cannot use a variable of type int where a float 32 is expected. This is where conversions come in. To solve this issue, we use type conversions. Here's how to convert an int to a float 32. You just place the type, float 32, in front of the value you want to convert. This ensures that both variables are of the same type when performing math operations. Here, we focus on the value being converted. The number 2 is the value we are converting into float 32. By wrapping it in float 32, we change its type to make it compatible with other float 32 values. This conversion is crucial to avoid type mismatch errors when performing operations between different types in Go. Now that we've converted the width to a float 32, the operations between length and width will work without any issues. We can successfully calculate the area of the rectangle and compare the values without running into type mismatch problems. Let's try converting a float 32 value to an int. In this case, we're converting the length variable from float 32 to int. This allows us to assign the length to an integer variable, but keep in mind that the conversion will drop the decimal part. After converting the float 32 value of length to an int, notice that the fractional part is dropped. This is a critical aspect of conversions in Go. Converting from float to int will always discard the decimal portion. Be aware of this behavior when performing conversions. Now, it's time for an exercise. We have a simple program to calculate the total price including tax and check if we have enough funds for the purchase. But the code currently contains some type mismatches, which we need to fix. We calculate the price, the tax, and the total cost of an item. However, there's an issue with type compatibility between price, which is an int, and tax rate, which is a float 64. In this exercise, you need to complete the code by fixing the type mismatches in the math operations and comparisons. Remember to use type conversions to make the values compatible before performing any calculations or comparisons. Now, let's check the answer. Here's the correct solution to the exercise. We've used conversions to make sure the math operations work correctly between int and float 64 types. The tax and total calculations are now correct, thanks to using type conversions. We've successfully converted the price to a float 64 before multiplying it by the tax rate. Also, we've made sure that the total is compared with the available funds using compatible types. This approach prevents any runtime errors and ensures the calculations are accurate. Conversions are an essential part of working with different types in Go. They allow variables of incompatible types to work together, ensuring smooth and error-free operations. However, always be cautious of how conversions might change the values, such as when converting from float to int. Understanding how to properly use type conversions will help you write more robust Go programs.